Okay, so now that we have explored what makes something a polynomial function, and we've looked at graphs of polynomial functions based on their end behavior and their x-intercepts, now what we're going to move on to is finding the x-intercepts that we couldn't find by factoring. So up until now, every single polynomial you've been given could factor in quadratic form or could factor by grouping. Now we're going to look at cubic and quartic and quintic functions that aren't factorable using those methods. And so we're going to learn two methods for factoring them. So the first thing we're going to look at is just division in general. So there's some terminology with division that we have to get used to. So something along the lines of, this is long division, okay? What it's showing is that this polynomial, x cubed plus 2x squared minus 5x minus 6, is being divided by x plus 1. So that's setting it up as a long division. The polynomial underneath the long division sign is called the dividend. So it's the number that you're dividing into, and it's shown with a p of x. The number that's dividing in is called the divisor. It's given the symbol little d of x. Then the answer you get, so when you divide x cubed by, or x cubed plus 2x squared minus 5x minus 6 by x plus 1, the answer that you get is the quotient. So the quotient is the answer of a division question, and it's shown with q of x. And then at the end here as well, if it divides in, you end up with a remainder. Now, here's an example of x cubed plus 2x squared minus 5x minus 6 being divided by x minus 3, so a different divisor. We get a difference quotient, and we'd get a different remainder. I want to talk for a second before we do the division statement about what the remainders mean. When you get a remainder of 0 versus when you get a remainder of 24. To do that, actually, it's easier to show it through the division statement. So a division statement states that your dividend is equal to your divisor times your quotient plus your remainder. So if we look at this one, x cubed plus 2x squared minus 5x minus 6 is equal to x plus 1 times x squared plus x minus 6 plus 0. Versus this division statement would be the same polynomial, so x cubed plus 2x squared minus 5x minus 6, but this time it's equal to the divisor of x minus 3 times the quotient of x squared plus 5x plus 10 with a remainder of 24. When the remainder is 0, we factored it. So x, well, we factored it regardless, but it is a factor. So when your remainder is 0, the divisor is a factor of the dividend. In other words, we could find the zeros of this function. If the remainder is not 0, something like 24, we can't use this to then find the zeros of the function easily because we can't use the principle of zero factors because it wouldn't be equal to 0, it would be equal to negative 24 if we were doing it as a product. All right, so now what we want to do is learn the long division. But before we do that, I want to show you a shortcut for finding the remainders. So doing this whole long division, or eventually what we do is synthetic division, can be a bit long to figure out if something is a factor. So in other words, if you're looking for something to have a remainder of 0. So there's another way to do it. What it is that if we look at this being my polynomial function, f of x defined as x cubed plus 2x squared minus 5x minus 6. If x plus 1 is a factor, so if this is a factor of this polynomial, it means my remainder will be 0. That should remind you of the word zeros. If this is your factor, then your 0 is negative 1. Which means if we plug x equals negative 1 into this equation, we should get a remainder of 0. So let's do it. Negative 1 cubed plus 2 times negative 1 squared minus 5 times negative 1 minus 6. If I plug that into a calculator, I get negative 1 cubed is negative 1 plus 2 times positive 1 plus 5 minus 6 gives us 0. Sweet. Negative 1 was a 0 of this polynomial function. In other words, x plus 1 is the factor. Well, what do you think is going to happen when we plug in x is 3? So we're checking, is this a 0? If we plug in x equals 3, will it come out to 0? So if we plug in x is 3, we get 3 cubed plus 2 times 3 squared minus 5 times 3 minus 6. Let's plug it in. 3 cubed plus 2 times 3 squared minus 5 times 3 minus 6. I get 24. That sounds familiar, because that was the remainder we got using long division. In other words, this remainder theorem, okay, it's called the remainder theorem, is that if you plug in the value of x that would make that factor equal to 0 into your equation, it will give you the remainder for your division. Okay, so we're going to use that. We're going to be able to use it to check, to make sure we've done our division correctly. We're also going to be able to check it to determine if things are zeros. Here we go. Let's do long division. So this is the first type of division we're going to do. It's going to be the hardest, I promise you. So don't stress out too much if you don't understand it. You will not be lost for the rest of the course, because long division is something that we won't do all the time, because there is a quicker division. But it's kind of like understanding the root of something. This is where the other division we're going to learn comes from. It's just a shortcut version of this. This is the long version. So there will be a question in your test that says show long division, so you need to understand this process, but you're not going to be doing this process over and over and over again in the course. All right, so here we go. Find the quotient and the remainder of the division of x cubed minus 2x squared minus 4, the dividend, by x minus 3, the divisor. Step number 1 is to set up your division question. So we are going to set it up that x cubed minus 2x squared minus 4 is getting divided by x minus 3. And the only thing you have to be careful of when you do that is you have to look for what I call ghost terms or missing terms. You need to add any missing terms in as 0x to the whatever exponent is missing. In other words, your dividend must be written in descending orders of power. It has to go x cubed, x squared, x, and then number. So since the x term is missing, you put it in as 0x. Okay, from here, what we're going to do is we're going to look at the process of division. Step number 2 is where the division actually starts. So we've set up the division question, and now we're going to look at the actual division. What you're going to do is divide the first term of the divisor, or dividend, sorry, by the first term in the divisor. So x cubed divided by x, and that gives you x squared. That is going to be the first number that goes into your quotient, x squared. So we did x cubed divided by x, and we got x squared. Then you're going to take that x squared in your quotient and multiply it by your divisor. So x squared times x minus 3 would give you x cubed minus 3x squared. That is what you then write underneath of that dividend. Then the next step is to subtract. So we're going to go x cubed minus x cubed is gone. So the whole goal of long division is to divide away a term at a time. So x cubed divided by, or subtracting x cubed is gone. And then we've got negative 2x squared, take away negative 3x squared, means we're actually going to be adding the 3x squared. So negative 2x squared plus 3x squared is x squared. And then you're going to pull down the next term, because if you have a 2-term divisor, you need to go into 2 terms of your dividend. And then we get to repeat the process. The process is divide, multiply, subtract, pull down, right? You can make some sort of fancy mnemonic with that. But we're going to repeat that process again. So divide. So what I mean by that is we're going to take the first term in our new dividend. So it's like now we're dividing into x squared plus 0x. So we're going to do x squared divided by x, and we get x. Okay, so you're dividing your dividend by your divisor, but only the first terms. The second terms kind of go along for the ride. So x squared divided by x gives me x. That's the number that goes in my quotient. Now I'm going to take that, I'm going to multiply it by x minus 3. That gives me x squared minus 3x. And now I'm going to subtract. X squared minus x squared is gone. 0x minus negative 3x is just 3x. And then you pull down. Then we're back to divide. So we're going to take the first term in the new dividend, so 3x. We're going to divide it by the divisor, so x, and we get 3. That's the number that goes up in my quotient, and then I multiply 3 times x minus 3. That gives me 3x minus 9, and then I subtract. This is where I see the majority of the mistakes. Actually, people are usually pretty okay with long division, but they can't subtract integers. So 3x minus 3x, all good. But don't forget, -4 take away -9 means you're adding 9. So -4 plus 9 is 5. And that's it. We're done. We're at the end. We know we're at the end because, again, I write my matching terms. So my quotient, like the x squared, I write above x squared, because then my quotient will go x squared, x number. And then when I get to the end at the number, I know I'm done. Okay. And I can write my division statement. So my division statement for this one would be x cubed minus 2x squared minus 4. So x cubed minus 2x squared minus 4 equals your divisor, which was x minus 3, times your quotient, which is x squared plus x plus 3, x squared plus x plus 3, and then plus the remainder, which we got was 5. So this also gives you another way of checking. If you want to check you've done it correctly, if you multiply x minus 3 by x squared plus x plus 3, and then you add 5, you should get x cubed minus 2x squared minus 4. Another way of checking would be using the remainder theorem. Let's see if we can get that remainder of 5. In other words, if I plug in 3 for x, remember, solve the factor, I get 3 cubed minus 2 times 3 squared. I don't need the 0x term, minus 4. If I plug that in, 3 cubed is 27, minus 2 times 9, minus 4, I get 5. It's a good way of knowing you did it right. I mean, if you get the right remainder here and it matches the remainder you got with the remainder theorem, you know you did pretty good. Okay, I don't think there's a way of doing it wrong and getting the right remainder. Okay, so let's do it again. So here's another question. This question says, use long division to determine if x plus 3 is a factor of x cubed minus 2x squared plus 5x minus 4. In other words, we're using long division to determine if we get a remainder of 0. If we get a remainder of 0, then x plus 3 is a factor of this polynomial. So the first thing we're going to do is set up the long division. So I'm dividing x cubed minus 2x squared plus 5x minus 4 by x plus 3. Okay, I made sure there was no missing terms. I went cubed, squared, 1, gone. And now I start doing it. So I'm going to take the x cubed and I'm going to divide it by the x to get x squared. That's the first term in my quotient. Then I'm going to take that x squared and I'm going to multiply it by x plus 3. That gives me x cubed plus 3x squared. So divided, multiplied, and now I'm going to subtract. X cubed minus x cubed is gone. Negative 2x squared take away 3x squared is negative 5x squared. Pull down, plus 5x. Then I repeat the process. Again, I'm taking the first term in my new dividend, dividing it by the first term in the divisor. I get negative 5x squared divided by x equal to negative 5x. Then you write that up in your quotient, and then you multiply. Negative 5x times x plus 3. If I do that, I get negative 5x squared, that first matching term, minus 15x. And then I subtract. Negative 5x squared, take away negative 5x squared is gone. And then I've got 5x, take away negative 15x, which would be plus 15x or 20x. Then I pull down the next term. Then I'm taking 20x and I'm dividing it by x, and I get 20. Some people do that a little differently. Instead of doing the division, they go, okay, what would I multiply x by to get 20x? And then they just put 20 up here. You don't have to do this whole division thing. I'm just trying to be very systematic to show you why you're getting what you're getting in your quotient. Okay, so again, you know, I take 20x and divide it by x to get that 20. Some people might think of it instead of saying, what would I multiply x by to make it 20x? And then they just write the 20 up in the quotient. But regardless, you get 20. Then you're going to take that 20, you're going to multiply it by the divisor, x plus 3. And then I get 20x plus 60. And then I subtract. I get 20x minus 20x is gone, and negative 4 take away 60 is negative 64. So since I got a remainder of negative 64, Therefore, x plus 3 is not a factor. Again, you have to get a remainder of 0. And again, if you wanted to check this, right, if you wanted to check, plug in f at -3, so the 0 of the factor. If I plug in -3 for x, I get -3 cubed minus 2 times -3 squared plus 5 times -3 minus 4. If I plug that into my calculator, I'm hoping I get -64. So let's check. -27 minus 2 times 9 minus 15 minus 4 gives me -64, right? I'm all good. I did it correctly. So if you're understanding this, this is a great spot to pause the video and give this one a go. And maybe just do a bit, see if you get that first line right, then watch me do it, and then do the second line. Okay, this question, again, it's a different wording in the question, but it's the same process. Again, it says use long division. So you are only going to be using long division when it says use long division, okay? But we're going to use long division to find the quotient and the remainder when the polynomial x to the 4 plus 3x cubed is divided by the divisor x minus 1. And then we're going to express our polynomial using our division statement. So the divisor times the quotient plus the remainder. So the first thing we're going to do is set up our division. So this is my dividend, x to the 4 plus 6x cubed. Then I got to fill in my ghost terms. I'm missing a 0x squared, I'm missing a 0x, and I'm missing a 0. These will kind of come naturally. You'll notice you're missing them when you're doing long division. They won't come so naturally with the next type of division, so get in the habit of checking always, right? Your dividend has to go in descending orders of power. And then we're dividing by x minus 1. So this time we're dividing a quartic function by x. And so we're going to have to, it's going to be a little bit longer. And one thing I want you to notice is that when you're dividing, x to the 4 by x, your quotient will start with an x cubed. When you were dividing an x cubed by an x, your quotient started with an x squared. Something to be aware of, okay? But maybe this is a good time now to pause the video. Maybe you already did and you're coming to see me do it right. Okay, let's go. So I'm going to say, what do I multiply x by to make x to the 4? Or I'm going to take x to the 4 and I'm going to divide it by x. I get x cubed. That's the first part of my quotient, and I write it above the matching term. Then I'm going to take that and I'm going to multiply it by x minus 1. That gives me x to the 4 minus x cubed. And then I subtract. And again, this is where the most mistakes happen. So x to the 4 minus x to the 4 is gone. 6x cubed, take away negative x cubed, mean I'm adding x cubed, and I get 7x cubed. Then I repeat. Whoops, sorry, pull down. So pull down 0x squared. So remember, 2 terms in your divisor means I need 2 terms to divide into. So now I'm doing 7x cubed divided by x gives me 7x squared. That goes up in my divisor. And then I multiply. 7x squared times x minus 1 gives me 7x cubed minus 7x squared, and then I subtract. 7x cubed minus 7x cubed is gone. 0x squared minus negative 7x squared means I'm adding 7x squared, and then I pull down my next term. And I repeat. So what do I multiply x by to make 7x squared? I multiply by 7x, right? Or take that 7x squared, divide it by x, and get the 7x, regardless of which way you want to do it. And then I'm going to do 7x times x minus 1. That gives me 7x squared minus 7x. Starting to feel very repetitive, okay? And I'm going to subtract. 7x squared minus 7x squared is gone. 0x, take away negative 7x is 7x. And then I'm going to pull down. Last one, 7x divided by x equals 7. Goes up in my quotient, and then I multiply. Seven x minus 7, and then I subtract. 7x minus 7x is gone. 0 minus minus 7 is 7. Whew! All right. Now we have to answer the question. So the question is, what they want to know? They want to know the quotient. So the quotient is x cubed plus 7x squared plus 7x plus 7. The remainder is 7. And then the division statement, I'll write it, I need somewhere to, actually it's not too long. I need a little bit of room. So the division statement I'll write down here. So x to the 4 plus 6x cubed, that's my dividend, equals my divisor, x minus 1, times my quotient, x cubed, plus 7x squared, plus 7x plus 7 plus my remainder of 7. That's it. That's long division. And again, you're only going to use long division when it says use long division. And again, you can check. If I plugged in x equals 1, I should get a remainder of 7 into my original equation, right? So if I was going to check, I would plug in, this is p of x, so p at 7, sorry, not 7, p at 1, and I would get 1 to the 4 plus 6 times 1 cubed. And look at that, I get 7. Woohoo, I did it right? It's that feeling of like, yes, I checked it and it's good. All right, before you watch the next video, at least try these 4, right? There's always more that you can try, but at least go and try those 4.